The classification algorithm means it's a type of decision tree. We'll discuss about the decision tree, and it's a type of the classification algorithm. What do you mean by classification algorithm? This is a type of supervised learning algorithm. In this supervised learning algorithm, there exists a label. Based on the label are the target variable. Some input variables are also there. Based on the target variable and input parameters, we will classify the given new value also. That is the concept of the supervised learning classifier. First, you should train the algorithm, and based on the training set, we can check the testing attributes also. So decision tree, when you're considering the decision tree, here it acts like a tree-like structure. So in this, a root node is there, followed by some sub trees are also there for the decision tree algorithm. For example, if you want to offer, some offer is there. If you want to join the job means, how can you decide the job? So many jobs are there in your hand. Consider you are the Parunian student. So during the placement, so many offers are with you. How can, in which basis you can select the job means, first you set about the salary. Salary is the main factor for you to decide the job generally. So first check the salary. If the salary is above some threshold value, automatically select the offer. Otherwise, decline the offer. Then next, you check whether it is nearer to hometown or not. Suppose the offer is at South Africa and one of the offers is from the Delhi means you prefer Delhi instead of the South Africa. It depends upon the location. So based on your location, you select that up. Then after that, first is salary. After you select based on the location, and then you select the facilities, whether they are availing you the facility for accommodation, food, as well as the traveling facilities. Everything is given by a company. That is, their salary is high, that is nearer to your place. They will provide all the facilities means automatically you will select that job. That decision, that based on some criteria, you will decide something. That is what called as the decision tree. This is example for job offering. Salaries between $50,000 to $80,000. That will be accepted. Otherwise, decline the job. Then check the office is nearer to home or not. If it is nearer, take that offer. Otherwise, again decline the offer. Then provides a cab facility. That is there, accept it. Okay, decline. These are based on some conditions, some features. We will select the offer. Second type is, should I quit the job? Decision tree. We can use decision tree algorithm for designing that also. Should I quit my job? You are going to quit the job means what are the constraints? You will check. If you are quitting any job, you should check the alternate job opportunities there. And if it is feasible to get another job, if it is yes, then you will quit the job. Otherwise, you will stay on the job. So here, should I quit my job? Do I have another job opportunity? Yes, then quit the job. Otherwise, wait for some more times for quitting the job. Then is it better? The next job opportunity is better one means immediately quit the job. Otherwise, remain in the particular job itself. So based on some factors, you can quit the job. Same manner, consider the Titanic. In this Titanic, in that one, all the female were survived. No, all the females survived, and when you consider the male passenger, if it is a child, then that is also survived. Two categories, two things. One is either a female. Female means survived. Otherwise, male under some year. Okay. And with more siblings, they survived. So based on the constraint, we will construct a decision tree for that also. Check whether sex is male or not. Female means automatically they were survived in the Titanic crash. And if it is kid, if the man with age greater than 10, all men died in that, and men less than 9.5 years means check whether the siblings are there. Siblings are there means they also survived, other died. So based on certain condition, here also the decision tree is drawn. In general, decision tree is a graphical representation of all the possible solutions to a decision based on a certain condition. All the possibilities are given in the decision tree. Then to classify, this is mainly used for the classification only. Green color and diameter is 3 means that is it's given that green color diameter is 3 means that's mango. Yellow color diameter 3 means lemon. Red color diameter 1 means grapes. Yellow color diameter 3 means mango and red color diameter 1 means grapes. These things are given. Suppose the next test case is red color 1 means automatically you can say that that belongs to grapes, but because already it's given that red color and with diameter 1 is belonging to a single group grapes. Similarly, yellow with diameter 3 is automatically lemon. Suppose I want you to check whether the fruit with features color is yellow and diameter is 3 means you go and check with the training parameters and it's given as lemon. So obviously you will say that this is the lemon. Suppose I am giving you something with the yellow color and diameter is 3. Yellow and diameter is 3. How can you define that whether this is the lemon or mango? Yellow or diameter. Green with the diameter 3 means mango. We know that. Yellow and diameter 3 means there are two possible classes, lemon as well as the mango. So what should we take? This kind of situation, we will go for the decision tree algorithm. The decision tree is the supervised learning algorithm. It uses the tree-like model of decisions. It's used for both classification and regression. Decision tree algorithms are referred to as CART, or classification and regression trees. Other name of the decision tree is CART, classification and regression trees. Generally, it's used for classification. We can use this for regression also. The links between these nodes represent the decisions, and each node is called as the predictor variable. In the decision tree, each and every node is called as the predictor variable. Each leaf node is the outcome. That is known as the response variable. The main things are, first one is the root node. The decision tree, first one is the root node. This is the root node, and then these nodes are called as the internal nodes, and next one is the leaf node, and the arrows are called as the decisions. Yes or no, each and everything, yes or no, survey or not survey. These are the decisions. So starting node of the decision tree is called as the root node, and internal node represents the decision point or the predicted variable. Move on to the next prediction. The leaf nodes at the lowest nodes, which represent the final class. Died or surveyed, these are the class. So final class is represented by this leaf node, and branches represents connection between the nodes. And splitting means dividing the root or internal node into different parts based on some criteria is known as splitting. Then if you're going to generate a decision tree, which one you should bring first? There are 6 features: day, weather, temperature, humidity, windy, and play. Which one can be taken as the root node? Which one can be picked first? And how do we choose the best attributes? Or how the tree can be splitted? These are some of the questions of the decision tree. To avoid that, we use the algorithm. The algorithms for the decision tree is first to select the best attribute. The best attribute can be selected based on certain procedures. I will tell that. First one is select the best attribute. Second one is assign A as a decision variable for the root node. Best attribute is selected and that is assigned as the decision variable, and that is the root node. For each value of A, build a descent of the node. Each and every value of A, possible roots are developed. Assign classification label to each and every leaf node. If data is correctly classified, okay, then stop it. Otherwise, repeat the same for each and every time. To split the tree or to make the tree, we need some informations. It can be calculated by Gini index, information gain, chi-square, reduction in variance. These are some techniques used for making the decision tree. Some of the algorithms used for decision tree classification. In our example, we will discuss the information gain. Information gain we use for this decision tree. There are many ways to construct the decision tree. One of the technique is the ID3 algorithm. The ID3 algorithm, we concentrate on two terms, entropy and the information gain. Okay, these are the two terms used in the ID3 algorithm. ID3 means iterative dichotomizer algorithms 3, and here the best attribute is decided based on the entropy as well as the information gain. A predictor variable is the best variable. The best variable can be calculated by using entropy and the information gain. Entropy means it measures the impurity or uncertainty of the data. The uncertainty of the data is calculated by the entropy, and information gain specifies how much the information affects the predicted variable. That is given by the information gain. Here, consider all are apples. Entropy gives the impurity among the data. In this example, the first example, all are mangoes. There is no impurity. So, entropy is equal to 0. Nothing is impure. All are pure apples. So, impurity equal to 0. So, the next one is, here it contains cherry, mango, apples as well as bananas. So, when you are considering the classification is the fruits, here the impurity is high. So many types of fruits are there, so impurity is high. That is, when you are classifying the data, if all data comes under the same category, then impurity is 0. If comes under so many different categories, impurity is high. The entropy will give the measures of the impurity. You should remember this one for calculating the information gain. Entropy is the measure of impurity. This is the bell-like curve, normal distribution curve. When you see this curve, if the probability is 0, that is all belongs to the class 1, then the entropy is all 1. Suppose the probability is 0.5, the entropy value is high. If number of yes equal to number of no, then probability equal to 0.5 and entropy equal to 1. If all yes and all ones, the probability is 1 or 0. In this case, entropy equal to 0. That is, impurity is there means then probability is also different. The formula used to calculate the entropies, you study this formula. Entropy of S equal to minus P into S log to P of S. Entropy of Y, this is for yes. Similarly, you can calculate for no also. Then you remember one thing, when you are classifying the terms, half of the items are positive and half of the items are negative. It's half are yes and half are no means, then the probability is equal to 0.5 and entropy is equal to, from the figure you can say that if probability is 0.5, entropy is 0. If probability is 0 or probability is 1, that is if all values are positive or all values are negative, the probability is either 0 or either 1. In this case, the entropy equal to 0. We will solve one problem by using this concept. Here we are going to calculate the entropy as well as the information gain IG. The problem statement is, for a given data set, create a decision tree and classify the speed of the vehicle as slow or fast. Here the various input attributes given are road type, obstruction and speed limit, whereas the target variable is speed. We are taking the speed as the target variable. 3 input variables: road type, obstruction and speed limit. Okay, the predicted variable is speed and the target variable is speed, and predicted variables are road type, obstructions as well as speed limit. First one is decide the best variable. Which one is? There are 3 things: road type, obstruction and speed limit. We should identify which one is the best variable. When you consider the road type, here steep, steep, flat, steep. The corresponding target is slow, slow, fast, fast. You cannot say that if it is steep, then speed is slow. Like that, you can't say that, because here the variable is steep and the speed is fast. So from this one, you cannot identify what is the best variable, and based on which one you can decide this one. So we go for this decision tree algorithm to decide the best variable. First thing is, the first step in the decision tree algorithm is calculate the entropy as well as the information gain. Okay, find the entropy and the information gain. Note on this one. I'm going to solve one problem. Based on this problem, we will solve another one problem in the class also. So you note down this thing and write the steps also. First, this is the problem statement. Take down this problem. This is the problem. First, take the target variable as the speed. There are two things, slow and fast. The next step is to identify the best variable. For identifying the best variable, you need to calculate the entropy as well as the information gain. Okay, calculate information gain and the entropy. Entropy can be calculated by using the formula minus sigma I equal to 1 to C PA log to PA. Information gain equal to information entropy of parent minus weighted average of children. You should know these two formulas. Entropy as well as information gain. Information gain equal to entropy of parent minus weighted average of E. First, to calculate the entropy, we need to find the information gain. We should find the information gain for each and every node. In which node the information gain is high, that node will be taken as the best variable node. First, consider the entropy of the parent node. For that, only select column. You know that this is the table. In this table, only select speed column. Slow, slow, fast, fast. Take this column. There are only two classes. What are the classes? Slow as well as the fast. The slow and fast. How many slow and how many fast are there? Slow is 2 and fast is 2. That is, when you calculate the probability, total 4 events, 2 by 4 for slow, probability of slow is 2 by 4 and probability of fast is also 2 by 4. So the value is 0.5. If probability is 0.5, we know that the entropy equal to 1. Okay. The entropy value equal to 1. So the entropy of parent node is equal to 1. Entropy of parent node equal to, when you calculate by using the formula, minus P into P of slow star log to P of slow plus P of fast into log to P of fast. When you calculate the value, you will get the entropy of parent equal to 1. Default, we know that if the value of P of slow equal to 0.5 and P of fast equal to 0.5, we know that the entropy value equal to 1. This is for the parent node. The entropy for the parent node is calculated and that is 1. Next. We are going to calculate the entropy for the next node. First, take the node's road type. There are 3 attributes: road type, abstraction, as well as the speed limit. First, take the variable road type. When you take the road type, what are the values in the road type? Steep and flat. There are 2 values. So take road type is steep or road type is flat. There are 2 decision variables. For this variables, steep and flat, you check on the table. If steep is there, what is the possibility for the target variable? Because we are going to calculate the information gain. related to this decision variable. Already we have taken the target variable as this decision variable as the speed. So for speed, we are going to find this road type steep and flat. If it is steep, what are the possibilities? Steep means just take it from here. Steep means one possibility is slow. So steep means first one is slow. Again, steep means second one is also slow. Again, steep means slow. Slow, slow. For this steep, this speed is fast. So for steep, three possibilities: slow, slow, and fast. Then for flat, there is only one possibility, that is fast. For flat, only one possibility, that is fast. We are going to find the information gain. To find information gain, we need the probability as well as the entropy. Here the probability is one by one. Only one is there, and that is fast. One by one probability. If the probability is one, only one possibility is there, the entropy is zero. There is no impurity. All comes fast. In this case, entropy equal to zero. The entropy for flat equal to zero. If your child, you are calculating first right child, the probability is 1. So for flat, the entropy equal to 0. If you calculate the value, then also you'll get the value 0. Then you find the entropy of left child. For this left child, find the probabilities. How many possibilities are there in the left side? 3 possibilities. Among 3, 2 is low and 1 is fast. So first you should calculate the probability of slow. Probability of slow is 2 slow and 1 fast. So 2 by total 3 events are 3 occurrence. Under the 3 occurrence, 2 is slow. So 2 by 3 equal to 0.667. And next fast is only 1 among 3. 1 is fast. 1 by 3, that is 0.334. When you substitute the values to calculate entropy, P of slow into log 2 of P of slow plus P of fast into log 2 P of fast, you'll get the value as 0.9. Now, the entropy of parent node is 1 and the entropy of the child node road type is equal to 0.9. That is given. Next, calculate the weighted average. Next thing is find the weighted average of the child. Weighted average means how many nodes are there under each and every node having how much priority. Totally in this parent node, how many nodes are there? 4 things. Slow, slow, fast, fast. Right child 1 and left child 3. Find the weighted average. Weighted average means in the right hand side, total 4, up 1 by 4. Among that, 1 by 4. Right hand side, 1 by 4 into entropy 0. Left hand side, 3 by 4 into entropy 0.9. So 3 by 4 into 0.9 plus 1 by 4 into 0. Calculate this value. This is the weighted average for this first thing, that is the road type. Same manner, calculate it for each and every attribute. Second attribute is abstraction. Take that abstraction attribute. What are the 2 possibilities? Yes or no. Yes or no. Yes means slow. No means here first is yes. First yes is slow. Yes and no. In the first yes, slow. Then next is no. Under no, write slow. Under no, write slow. And under yes again write fast. Under yes again write fast. Under no again write fast. Under no again I have written fast. Slow left hand side as well as right hand side. 1 slow and 1 fast is there. What does it mean? Total 2. Among 2, 1 is fast and 1 is slow. So the probability is 1 by 2 for the slow in the left hand side. For the left child, you are going to calculate the entropy. When you are calculating the entropy for left side, probability is slow is 1 by 2, fast is 1 by 2. Right hand side also probability of slow is 1 by 2 and probability of fast is 1 by 2. 1 by 2 means probability 1 by 2, that is 0.5. If the probability is 0.5, we know that entropy is 1. So in the left hand side as well as right child, the entropy is 1. Entropy means impurity. Impurity is 1. Then weighted average you calculate, totally 4, left hand 2, right hand 2. So 2 by 4 equal to 1 by 2. So the number of 1 by 2 into Entropy of left node and entropy of right node, 1 by 2 into 1 plus 1 by 2 into 1, that is equal to 1. Same manner, you find the information gate for the child node speed limit. Take speed limit now. Yes, yes, no, no. So two classes, yes and no. Two classes are there. For yes, slow, 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 slow. And for no, fast, fast. For no, fast, fast. So yes, yes, and fast, fast. When you find the entropy, here the probability equal to, this is 2 by 2. Here probability is 2 by 2, that is equal to 1. If the probability is 1 or 0, we know that the entropy is also equal to 0. So here the entropy equal to 0. Both are positive. There is no impurity here. Both are 0. Here both are fast. Nothing is impure. So the entropy equal to 0. Now calculate the weighted average. Total 4. 2 by 4. Right side also 2 by 4. 2 by 4 into 0 plus 2 by 4 into 0. The value is equal to 0. Here the weighted average is 0. Now we have calculated the weighted average for road type, abstraction as well as the speed limit. Find which one is higher. And you first find the information gain. Information gain is the factor that affects the selection of this variable E parent minus weighted average of E. For the first node, information gain for road type, information gain equal to 1 minus the weighted average 0.65, that is 0.325. Again, calculate the information gain for abstraction, that is 1 minus 1 is 0. Information gain for the speed limit, 1 minus 0 equal to 1. So, information gain is higher for the speed limit. Your prediction variable is speed limit. Take speed limits at this prediction variable. And see this table, speed limit as this prediction variable. And this is the tree that have been taken. Speed limit yes or no. For yes, 2 factors, and for no, 2 factors. This is the best variable for the decision tree. For the given example, this one is the best variable. Here all values are yes and no's. So no need to, if all values are yes, no need to expand it again. Same thing we will solve in the class for the next example tomorrow. So you should remember 3 things. For the decision tree, first you need to calculate the probability. Second, you need to calculate the information gain. And then for calculating the information gain, we need the entropy. Entropy can be calculated, and with the help of entropy as well as the weighted average, we can find the value of the information gain. For which variable the information gain is more, that can be selected as the best variable. These are about the decision tree. We'll solve one problem in tomorrow's class for better understanding.